Hey, what's up guys? Welcome back to the channel. Hope you guys are all doing well today, and I hope you're ready to learn a little bit more about iOS and Swift development. In today's video, I'm going to teach you guys how to use face detection by utilizing a new library called the Vision SDK that was introduced by Apple in the last WWDC. Now, what exactly is face detection? Well, Facebook uses this feature a lot where they allow you to tag either your friends or yourself in a lot of the images that either you post or your friends post. So let me go ahead now and show you guys a very quick demo as to what kind of application we're going to be building today, and then we'll dive into the code right afterwards. Alright, so what you're seeing in the simulator on the left side of the screen is an application that I've built out that already integrates face detection using the new Vision APIs. And the way it works is every time I click on one of these pages, it goes ahead and fires off the face detection algorithms, and it pretty much provides me exactly where I can draw a box around a face. And so this is just one face right here. And if I scroll over to this image, you'll notice that it has 4 faces, and the algorithm does a really good job at identifying each and every one of those faces. And right here, this is the third image, and you'll notice it gets this face right here, but it's not able to recognize this little small face on the top left corner. Now let me slide over to this Golden State Warriors image, and if I try to fire off the face detection, it's only able to detect Klay Thompson on the left, Stephen Curry in the middle, but it's missing the Draymond Green face. So as you can tell, the algorithm itself is not perfect. So one more image right here. If I click on here, it's going to detect this face, this, and this little referee in the back. So sometimes it does a good job, and sometimes it does a really good job. And finally, if I click on this image right here and try to detect the faces, it actually takes quite a while to finish the detection algorithm. And for the most part, it gets 1, 2, 3, 4, 5, 6, 7, 8, 8 or 9 faces inside of this entire picture. It's missing this one right here, and on the left side, right over there. So for the most part, it's pretty good. And I'm going to try to run the detection on this image, and let's see what we get. All right. So it's not able to recognize this, and this face. It's only able to recognize George Washington on the left side. So whether or not you consider this accurate is kind of up to you. All right, so now that I have your attention, you're probably wondering, how easy is it to integrate the face detection inside of my iOS application? Well, surprisingly, it's actually quite simple and straightforward, and I'm going to show you guys how to do it using this new single view application right here by first running the app to show you a blank white screen. So this application does absolutely nothing, and it's a pretty good starting point for us today. All right, now the first thing I need to do is to somehow put an image inside of this view controller so that it spans the entire width and also maintains the aspect ratio of the image, kind of like this right here. So the way to do that is to construct an image view somewhere inside of view.load. So I'm going to do this programmatically with let image view equals UI image view, like so. And I'm going to use this image constructor right here. And the first question is, what exactly is this image? Well, let's create it with an image right above. So UI image, and I will use the named string constructor. And the question is, what exactly is this string? Well, I'm going to drag in an image inside of my assets right here, and I have an image called sample1, and this is what it looks like. So it's quite large, as you can tell by this preview. So let's close out of that and use sample1. So sample1, let me copy that, go back to the view controller and use the string of sample1, there it is, and plug an image right below. All right, so let's just remove that comment down there as well. And now that we have this image view, how do we get it inside of this view controller? Well, a lot of you guys probably already know, but you can add in view.add subview of that image view to make it show up. So good stuff. And now I can run the app, and you should be able to see something inside of the screen right here. All right. So this is, again, a rather large image, and I want to show you guys how face detection works, but it's a lot easier if the aspect ratio is maintained. So what I mean is you should set image view.content mode, and you want to set it to scale aspect fit so that it maintains a 1:1 ratio for the width and the height, or the correct ratio for the width and height. So as you can tell, it's still kind of large. And to fix this issue, I want to set a frame manually on the image view. So let's say image view.frame equals cgrect. And why don't I use the constructor of xy00. Width, I'm going to use view.frame.width, and the height, let's just say 100 for now. Okay, let me run this app, and I believe you'll see it, the image kind of floating in the center of the view controller. So that's obviously not correct. And the problem is that this height value of 100 is not correct. So let's use the background color of perhaps .blue on the image view, and you'll see the apparent reason why the height is not correct. So that's 100, and we need to figure out what the correct height needs to be. So if I guess a value at 200, it's actually not correct, and it actually needs to be larger. So instead of randomly guessing, let's figure out what the correct height needs to be based on a couple of different values. The first is the original image's width, and then the view controller's width, and based on that ratio, we can figure out what the height is. So a little bit of math here, and I'm going to calculate it for you so that you don't go crazy over the math. So let scaled height equals the images, so image is this image right here, which is on line 16. You can say image.size, and you can get the actual width from it right here. And I don't really want to deal with these optional question marks, so to fix that, I'm going to apply some optional binding on the image with a guard statement like so. That means I can get rid of this question mark, which it should tell me to do so. So all right, good stuff. Now the ratio, I'm going to use the view controller's frame.width divided by the original image's width, and I'm going to finally multiply it by the original image's size.height. All right, so this is a scaled height, and let me just copy that and paste it into the height value and try to run the application again. So it should be okay, and like you see here, it's working. So some of you guys might be wondering where this comes from, or where this calculation comes from. It's basically a ratio of the image's width, and you just multiply it by the height, and then you get the scaled height. It is a rule that follows from having two similar rectangles. You can calculate the missing leg or the missing side just based on a ratio like so. All right, so don't worry about that too much, and I want to be able to set this up so that the face detection is easier to explain. And here we go. Let's see how we actually perform the face detection inside of an application like this. And it's actually pretty easy, but first you need to import vision. So let's import vision. All right, so what I can do with the vision SDK is to start detecting the rectangles that represent the faces inside of my image. And to do that, I'm going to use a new API called VN detect face rectangle request like so. So quite a long name. And you want to construct it using some kind of completion handler. Okay, so let me get some extra space down here. And what I'm going to do is to let request equals all this stuff here. And for the completion handler, just hit return, and you'll get some auto completion code. And the first parameter is the actual request that you get back. And then the second parameter is some kind of error object, which you should probably check with this optional binding syntax of, let's see, print failed to detect faces, and just print out the error like so, and then return if you're not able to get the face detection to work properly. And down here you can just say print request. Now the question is, what exactly do I do with this request object? Well, there's also another API, which I believe it's VN image request handler like so. You want to construct this guy using some kind of CG image and options. Now, what exactly is this CG image? Well, you can get it from this image object up there. So I'm going to say image.cg image, but it expects you to use a non-optional image. So I'm going to say guard let CG image equals image.cg image, otherwise return. And let's just use this value here for this entire blob of data. And for the options, I'm just going to construct an empty dictionary like so. All right, so let's just say let handler equals that guy. And what I do with this handler is to say handler dot perform one of these requests guys, and this expects you to pass in an array of requests, which conveniently is just one request up there. So let's use an array of that request. And this guy right here can potentially throw an error. So what you need to do is to wrap this inside of a do catch block. So do catch, let request error perhaps, and dump that perform inside of the do catch. All right, so the error message is just going to say fail to perform request and print out the request error right afterwards. And now what you can do is to actually run the application. So let's just see what this does. First, we need to execute a try in front of the perform. And I'm going to put a breakpoint on line 42 to see the code or the execution being handled right there. So it's going to try and then put a breakpoint on line 31, hit the continue. And when it's done executing that request, it'll actually print out the object that we get back, just like so. All right, so we actually get a detect face rectangles request back from the actual request. Okay, so how exactly do we want to use this return request object right here? Well, there is a property on the request called results, which is in any array. And I'm going to execute a for each loop on this array. So you just hit return, you get this guy. And for each one of those values inside of the array, I'm just going to call it res. And down here, why don't I print out exactly what res is and also remove the above print statement. So let's run the application, and after it performs the face detection request, it'll print out something down below, which is on line 37 right here. And you can see it is a VN face observation. And because this res thing right here is of type any, I need to cast it into this face observation in order to start using it. So what I mean is I want to say guard let face observation equals this res guy from above. So this res, and I'm going to cast it with as question mark VN face observation like so, otherwise return. All right, and face observation has this thing called bounding box on it. So let me just print out that to show you what it is doing. So basically you see these 4 values right here. That is the bounding box, and I'll just run it to show you exactly the print statement down in the console. So we get these 4 values. Now some of you guys might be having a question as to why this result is an array. Well, basically inside of your application, you can have multiple faces such as this image. So the results will be an array of face detections, or face observations rather. Okay, so hopefully you guys are still with me here. And the question now is, what exactly do I do with this bounding box property on face observation? Well, why don't we command click onto it and jump to its definition. And it says that the bounding box is the box of the detected object. And in this case, it is the face right here. And it also says that the coordinates are normalized to the dimensions of the processed image, with the origin at the image's lower left corner, which is down here. So you got to keep that in mind. It is the lower left corner and not the top left corner. So let's go back to the view controller file right here and see what we can do with this bounding box property. So what I'm going to do is to try to use this to draw a red view on top of my face. And why don't we do this one step at a time to make it easier. So let's construct a red view with UI view empty constructor red view dot background color equals dot red, and I'm going to set a frame on it so it shows up with a CG rect of XY width and height of 0, 0, and 100. Let's see, 100 and 100. Finally, I need to add it into the view controller's view via add subview of the red view. You can try to build this, but I believe I need a self because this is an entire closure block. So let's try to run this now and see if we get anything at all inside of our view controller. Okay, so it's loading, launching, attempting the face detection request, and we get this red view on the top left due to this frame setting right here. Okay, so time to use this bounding box property. And the bounding box is a CG rect, so this is the X value, this is the Y, this is the width, and this is the height. And to do this, to draw this over my face, I'm going to use the X value right here for the X value up above in the CG rect by first saying let X equal something. And what is this something? So this 13 to 9 right here is the actual percentage of the entire view from the left side in which you should draw this red box. So what I mean is you should do this right here, view.frame.width times face observation.bounding box. So pretty much 13% of the entire width, which is going to start somewhere right here on the left of my face. And you need to actually say .origin.x to actually get this X value right here. So let's use this X instead of this 0 value to see what we get. And I think I need a self right here. And let's try to run this. And we're going to translate that red box now from the left side, just 13%. And you'll see it lands pretty close to my face, a lot closer than it was before. Okay, so that's the easy part, the left side of the red box. And to make this a little bit easier to see, let's set the red's alpha value to perhaps 0.4 so I can still see my face and see how accurate we're placing this red box. So here we go, face detection, and there it is. So we need to move it down some more. And so that's actually the harder part of this entire calculation. And I would like to first start off by setting the correct width and height. And this is also very easy if you just say let width equals something. So let's say self.view.frame.width. I'm going to multiply by this value right here, the 30%. So let's say Facebook observation.boundingbox.width, and you'll get the width. And likewise, you can get the height via self.view.frame.height. Is that correct? No, that is actually not correct because the entire height is from the top all the way to the bottom. And what we need instead is the scaled height. And conveniently, it is up here. So this is the scaled height. So let me grab that. And let's just use this times the face observation.boundingbox.height, like so. And now we have width and height. So let's see what the box looks like once we plug in these two values. And it should be a little bit bigger than just a value of 100 and 100. So face detection request, and we get it back. And this is a lot larger than 100, 100. Okay, so the difficult part is to figure out what the y value needs to be. So let's see, let's declare a little bit of space here, let y equal something. And because the y value is actually from the lower left-hand corner, it's not as simple as doing the x calculation of calculating a percentage of the image's height. So this is probably what you would try to attempt at first. So you would say scaled height times Facebook observation bounding box, and you would use height like so, and that's actually incorrect. So let's see, pump that in there, times y, and let me show you why that is a mistake. And let's run this, and let's get this to show up, face detection, and once it comes back, it actually lands it right there somewhere. All right, so the correct calculation is to actually use 1 minus the bounding box's y value, and that calculation looks kind of like this right here. So 1 minus all of this, and I think I might be able to run this. So running, and let's see exactly where that red view is going to land inside of our image. And let's see, it actually lands somewhere below my face right here, and that's because again the bounding box y value is starting from the lower left hand corner. And to fix this final issue is to simply subtract the height of this entire box so that we can shift it up just a little bit. So I'm going to use the height value and bring it up here so I can subtract it right there. And finally, run the application. The red box should appear right above my face so that it is much, much more accurate than it was before. So pretty good stuff, and a lot of this might be a little bit hard to follow at first, but once you figure out the math and what all these values kind of correspond to, it should make a lot more sense. So before I let you go over today, I'm going to use this image called sample2, and this is what it is right here. And let's see if it works by modifying sample1 to sample2 up there. And we're going to run it to see all of the red boxes that get drawn from this results array inside of our image, which looks like that right there. So 1, 2, 3, 4, and that looks pretty darn good. Something that some of you guys might be noticing is that it takes a while to load the actual image when the application finishes running. So why is it happening, right? Why is there such a long wait? Well, this image request handler perform is actually, it seems to be a synchronous operation. So what I would do instead is to actually invoke all of this code inside of some kind of background thread via a dispatch queue call like so, global of a dot background using .async, and all of this code in here will be executed on a background code. So let's just copy all of this here, cut that, paste it in there, and try to run our application now. And hopefully we'll see the image come up rather quickly like that. And then it's going to attempt to draw the red boxes onto these faces when it's done. However, there's a problem because all of this code here, UI view init, this needs to occur on the main thread again. So like what we did before, let's use dispatch queue main.async to get back on the main thread, and I will copy all this code and perhaps just paste it in there, get rid of these couple of lines, and we should be good to go here. So running, we'll see the image view get drawn on the view controller, and once the face detection is done, it'll draw all of the red faces or red boxes on top of the faces like so. Alright, so that's going to wrap it up for today's video, and as you can see, the face detection API is actually not that difficult to implement, and I think it's actually quite simple and straightforward. If you want to download the source code for everything that you saw in today's video, make sure to check out the link down in the description below. And also, please leave a comment down below if you want to see the entire source code for the demo that we saw in the beginning of today's video. Don't forget to leave a thumbs up for the video and also subscribe to the channel if you haven't done so already. And hopefully I'll see you guys in the next video. Bye bye guys.